Thank you, Dr. Neitzel. Very excited to be here. So I'm an assistant professor of mechanical engineering here at the University of Michigan. I was lucky enough to go to both to Thailand and Chile, work with our wonderful collaborators to go out and just see how some of the people were doing some of this e-waste things. I was brought in mainly because we've been talking about sort of what is, I'm not going to go into why e-waste is a problem or sort of the global scale of it, but more talk about what are some of the opportunities that we saw of doing some observation and participatory actions with these e-waste collaborators around where can we make improvements? So as an engineer, my whole job is to try and make improvements. So we want to try and improve the process, and what does that even mean? How do we define that? Mainly, I'm hoping that in my short talk, we can talk about, so this is e-waste recycling, this is a picture from Thailand. Everyone else earlier in the day has much more expertise on that. I don't want to pretend that I'm an expert in that context. But what we can talk about is sort of this e-waste cycle. So what you've been seeing today is people talk about sort of waste generation. So whether that's local or global, waste generation is happening. Then you sort of have this waste collection. So people are going around either doing waste picking or in some way getting that e-waste to other people, who are then doing demanufacturing. So most of what you've seen today when we talk about e-waste workers, and I brought up the question earlier around what is recycling? What do we mean by that word? I think a lot of times when we're talking about e-waste recycling in this context, we're really talking about the demanufacture of products, and I'll talk a little bit more about that in a second. Then the final step, well, not the final step, the second to final step is this re-engineering. So taking that material that you've demanufactured and turning it back into engineering products, so raw materials, right? And I want to be clear here, and this is a little bit of a subtlety. If you take copper, you take aluminum, you take steel, and you're recycling it, you're not getting back the same aluminum that you had originally, okay? So there's like 50, in industry, they'll have like 50 grades of aluminum, which is different levels of scraps or sort of purity. Well, how much impurities do you have? What are the mechanical properties of that aluminum or copper or other things? So we want to be clear that when we're re-engineering, we're taking that scrap, and there's going to be different grades of scrap in different ways. So those questions earlier about, with sheathing on, with sheathing off, where is it coming from? All those things are going to determine not only the price, but how it's used in the engineering sense, okay? So the important thing is that really we're focused on sort of this demanufacturing process, okay? So understand that there's other parts of this cycle, but today I'm going to be talking about the demanufacturing part. There's other improvements we could make in other parts of the cycle, but I'm going to be focusing on demanufacturing. So we talked about stakeholders. Again, I'm not an expert, but it's important to know who the players are. So these are some of the players that are going to have impacts on the engineering decisions that you might make in terms of an intervention, whether it's a machine or a process improvement or any other things. You really want to understand how all these different actors play together, and then also what your change, what impact that might have on their use of your product or other products based on that, okay? So when we were in Thailand and in Chile, we saw mainly three things. So I'm going to focus on three things today, and those are TVs. So right here, people were talking about TVs, and this is both from the surveys that were done and collected by our collaborators, but also from our observation. People are mainly doing TVs, washing machines, and refrigerators. So those are the big ones. Now there are other ones. They do fans, they do computers, other people repair and do other things. But in terms of like a large scale where people are getting, in particular, we're going to focus on copper. This is where they're going, okay? So if we look at the TV and you break it apart, they're really going after what's called the yoke, okay? So this goes on the back of the CRT. This is the coil that directs sort of the electron stream in order to generate the picture, right? And that's where most of the copper in the TV is. And so they're trying to get that out, so they're breaking apart this TV, and you'll see videos, and other people are going to go more into this later. I'm really going to talk about the process. But to know what they're going after this copper here. They're getting plastic from the otherwhere, and then they're getting printed circuit boards from inside. And some of those are being sold for repair, as repair parts. So some people are doing that, so taking apart, keeping that printed circuit board intact. And others are just breaking that down and selling that as scrap. In terms of washing machines, and I'm sorry I'm going so quickly, but I only have 15 minutes, and I love talking, so it's just got to go fast. You're going to see here they're getting the motor. The main thing they're going after in washing machines is actually the motor. Okay, so they take the motor, and I actually brought one with me today, imported it straight from Thailand. You should have seen the customs decision we had here. This is the motor here from a washing machine. So there would be a pulley up here to operate the washing machine, and they want to get both the iron, so sort of the heavy metal, out of this, and then also the copper that's inside, and I'll just pull it apart a little bit, and you can see there's copper windings in there. So that's what they're going after here. So they're going after the steel, the copper, and they also do the plastic, but people are really concerned with the things that they can most immediately and quickly get their money back from, right? So they're trying to have a lot of value in terms of high-value materials that they can sell, but also do it very quickly, okay? Also, they get really angry. Motors are starting to be sold with aluminum windings that are painted to look like copper. It's really annoying if you're an e-waste recycler, let me just tell you. All right, so it's actually a very, very similar motor that's inside the compressor for a refrigerator. Looks something like this. So they'll cut apart this steel cage. We'll talk about that in a second. They'll take some of the plastic out and recycle that, but mainly are going after this copper. Again, copper is something that if they can get down to the bare copper, it's high value, and they feel like they can extract profit from that. So the metrics, when we think about engineering, we're thinking about, well, how do we know whether something's successful? What are we improving, right? What's the desired situation that we want? From an engineering perspective, we're really looking at two things when we talk about manufacturing. One is the recovery rate. You saw a chart earlier that Rick showed that's talking about informal versus formal and the recovery rate. So how much of the copper that is inside the consumer product are you getting back out when you demanufacture it, okay? So that's the recovery rate. Throughput is another one, and this is how much can you do? How quickly can you do it? Right, so this is sort of the main trade-off balance when you're looking at the demanufacturing process. Now, this is not the balance that you're looking at when you look at recycling as a whole. There's a lot of other considerations, energy considerations, other things. But if you're focusing just on demanufacturing, you're really concerned about how much copper am I getting out and how quickly did I do it. We also want to talk about safety and usability, and then finally profit, right? So there's a lot of things, and really I want to leave this conversation because we're going to have a panel later, and I really want to just have a discussion with all of you. I want to leave you with the main question, which is, how do the e-waste workers and other people that might use an intervention that we design, what is the value proposition? How do they see value? How do they measure value? How do they make those decisions? And these are some of the metrics we might look at as engineers, but there are obviously other ones that people care about. So let's just talk about the process really quickly. So when you're doing this recycling, trying to get back to the main material, the main way it happens, you start with dismantling. So you take apart the product, then you shred it. Okay, this may not be happening at the e-waste workers. This is happening at sort of the medium scale collectors that are collecting from the e-waste workers. So you shred it down, and then you have a separation. Now, in the informal sector, mainly people, and if you look at sort of any of the literature on this, people are mainly just doing dismantling. So they do manual dismantling of some kind with rudimentary tools. I brought some of them here. So you might modify a lawnmower blade to be able to chisel apart that motor, take apart sort of the steel transformer and be able to get that. And in the formal sector, if you were to do something here, there is some manual dismantling because you actually get that higher recovery rate that we were talking about. But mainly you just put it into a shredder or crusher. You take your computer, put it directly into a crusher or a shredder, and then you can separate those using, and these get different materials out. So your magnet's going to get ferrous materials, your eddy current's going to get aluminum and copper, then you have air separation, density separation, and screen separation. These are just in general. There are other techniques. I'm not covering everything. I'm just showing you that there's this spectrum where you can do these things very, very quickly. So you can do a lot all at the same time. Whereas over here, you can get a really high recovery rate. So we're not getting back the copper that's in the tiny transformer. That's just going straight in the landfill. Okay, we're not even collecting it. Whereas the people that we saw in Thailand are taking each transformer, busting it apart manually, getting all that copper back, so they have a very high recovery rate. And in fact, a lot of the papers suggest that in the formal sector, how do we do this manual recovery better, right? Because we want to be able to up that recovery rate. The problem is that there's some limitations about how fast you can do that, right? So the opportunity here, I think, really is improving the throughput, safety, and usability of the manually dismantling process, right? So a lot of these e-waste workers in all of the countries that we saw this morning, or at least the 2 countries that I went to, are using manual dismantling and really see an opportunity for themselves in terms of value of, well, if I could do more of this, it would be better, right? There are also questions about safety. So we're here, school of public health. Obviously, we care about the exposure. We care about these things. But I'm not sure, for some actors, that was a driver. But for most people, throughput was the driver. So in engineering, I want to do something that does this more quickly, but also does it in a safer way, right? So that's the opportunity. So let's just talk quickly about how they did this. So for TV dismantling, you saw a video. You're going to see videos later. The key thing is you're using sort of manual processes. So if you see here, you're unscrewing with a screwdriver. Maybe you have an electric screwdriver, but you're doing this manually. Or you drop it. That's another way to do it. Then you can snip the wires, you remove the controller board, you're doing all these things manual, you remove the degaussing coil, you separate the deflection yoke using a hammer, you break the yoke to get the copper coils using a hammer or a chisel, then you manually separate the copper from the yoke scraps, okay, using pliers or some other thing, right? So what you can see here, what I'm saying is that, you know, we can get into the details of the process, we have a lot of videos of it, we have lots of observations of it, but the key thing is all this is happening manually, right? And the opportunity is, how can we do this faster and do it safely? Because there's actually, so this takes about 7 to 20 minutes per TV. You have cuts from the glass and ledge exposure, so you have this CRT, which is coated on the inside with lead, and you're dropping it to break it open, because that's the fastest way that you can do it, right? So then the question is, okay, well, we have to do better than that, while also, we only have 1 minute? Okay, so let's keep going. So then we dismantle washing machines, we can talk about those things. I think the main opportunities that I want to talk about, so let's get to opportunities. I think the opportunities here are in fixturing. So how do you hold these things quickly? So a lot of people are holding it on the ground with their foot or putting it in different ways. So are there quick vices or things that we can use? Processing, so we've talked about shredding and burning wire. So what are ways that we can process this more quickly and in a more safe way? So that's the challenge that we face. And then finally, one that sort of surprised me, doesn't have to do with sort of this at all, but a big bottleneck is actually in the moving of goods. So if you have a washing machine, it's coming to your scrapyard, you want to go dismantle it, you have to move 10 washing machines. That's actually quite hard and causes a lot of injuries. So then that's another area where we could have improvement, increase the throughput, and increase the safety. So that's an interesting area for possible improvement. And then finally, I'll just leave you with these questions. For me, the big question is, what is this value proposition for the stakeholders? Not just the e-waste workers, but all the stakeholders, right? And so that's the policymakers, that's everybody. When I design something, if I'm designing something, there has to be value to everyone that's touching it, right? And enough value that they'll change their behavior. And so I've proposed that throughput and safety are two ways that we have this opportunity to do it. Some areas to do it in, I'd love to discuss further. I think the interdisciplinary part is like safety, profit, social benefit, environmental benefit. These are all things that are not necessarily the purview of mechanical engineering, right? But we want to make decisions based on this value, which is based on these things. So I think that we need to have a discussion as a whole group about what is the way forward if we want to tackle these challenges. We want to do it in a way that has positive benefit for those. Also system dynamics. If I increase the throughput, does that make the price go down to where it's no longer economically feasible? Right? If I increase the throughput, how does that change the system? What are these system dynamics? How does that impact the best decision that we can make? I'm sure other people are going to talk about that. And then finally, variation in users and operating context. These are all questions that we can ask at the panel. I'm sure that I'm over time, so I'm going to pass it on. But thank you very much.